Hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mass coder this side. So in this video we are going to discuss the question minimize maximum distance to gas station. The problem says that you haven't provided with a number line. You have provided with a number line. I am sure that all of you know about number line, and there are points marked on it, right? Points marked on it. Suppose there are 2 points marked on it as 1 and 5, right? Now it means that there is a gas station at point 1, there is a gas station at point 5, right? Distance between these two is 4. That is pretty evident, right? Distance between these two gas stations is 4. Now the question provides you with some k. Suppose k is equals to 1. Okay, k is equals to 1. Now the question says we have to insert these number of stations, that is k number of stations, in this interval such that the maximum distance between any two adjacent stations is minimized. So what do I mean by that is I'm saying 1 and 5. I have a point 1 and I have a point 5, right? Distance between them is 4, right? I want to insert one station. I can insert it here, I can insert it here, I can insert it here, in any range, right? I can insert anywhere, right? So suppose I insert it here. Suppose I say, let's say I insert at 6, right? So what does my array become? It becomes 1, 5, 6, correct? Now, if I calculate the adjacent differences, it will be between 1 and 5 it is 4, between 5 and 6 it is 1. The maximum among these is 4. Maximum among these is 4. So I will say the 156 will give me a maximum distance of 4. Moving on, I can also insert at, let's say 1 and 5, 3 is here, right? So I can say 1, 3, 5 is another array, right? If I calculate the differences here, it will be 2 here and 2 here. Maximum difference in this case will be 2. Similarly, I can insert an operator here, that is 0. Let's suppose 0. So it will be 0, 1, 5. Again, what is the maximum difference? So it is 1 here, it is 4 here. So I will take the maximum one, that is 4. So as you can see, among these three cases, 2 is the minimum answer possible. 2 is the minimum answer possible. It might not be the correct answer, but among these three cases, 2 is the minimum answer possible. So I will return 2. Okay. Now the problem says that you have been provided with this array, right? There can be multiple gas stations. K can be a value, certain value, not only one. It can be greater than equals to 1, that is 2, 3, 4, right? Suppose like that. Now you will have to give me the minimum possible maximize answer, that is this value, right? So you have to drop down to the minimum possible. The minimum possible, right? So let us continue how we will do it. Okay, so I'm inserting the direct optimize approach here because I was not able to find a brute force approach for this problem, right? That is why the video was also late. I was not able to find a brute force approach. For you, I'm bringing out the optimized version. Hope you will like it. Okay. So how we will solve it? Suppose my gas stations are linked at, it is at 1, 2, 3, 4, 5, right? And suppose I have a gas station here at 1 and a gas station here at 5. Now I have k equals to 2. Suppose I have to insert 2 stations, right? Now it should be pretty evident that I want to reduce this distance. This is currently 4, right? I want to reduce this distance. So it is pretty evident that I will not be inserting any station here or any station here, right? Because this distance will remain 4 and my goal should be to decrease 4 as much as possible. Also tell you, we have to return a double value. Right? So my target should be to reduce 4 as much as possible. Reduce maximum distance currently in array. Right? This should be my target to reduce 4, right? If I will insert, let's suppose 0, or if I will insert 6, then that does not make sense. Why it does not make sense? Because it is at 1, I agree, but the maximum distance will still be 4, right? And if I insert it at 10 and maximum distance become 5, that is also not favoring me, right? So I will insert it in this interval only, right? In this interval only. Suppose there was a 3 station on 3 also, so I would insert here or here, right? And the sum of these two can be k. Okay, so this will be my approach. So what I will do, I have a station at 1, I have a station at 5. Now what can be my minimum possible answer? If I am trying to target the answer exactly, if I try to find out the answer, what is the minimum possible value of answer? It can be 0, right? There is no distance less than 0 because distance is an absolute value and distance will always be greater than or equal to 0. So minimum possible distance is 0 0.0 because we are dealing in doubles, so I will taking at 0 0.0. This is my low value, right? And similarly my high value, as we discussed, we want to reduce the maximum distance. So I will calculate using a loop, using a loop that will calculate the adjacent differences maximum. That will be my high. That will be the adjacent differences maximum. Now I am all ready for to run a binary search. I am all ready to run a binary search. Now what is the elements I will be running on the binary search? So I will be running the binary search on my answer, right? On my answer. So my approach would work something like this. Now I will say my low is equals to 0 startingly. My high is equals to, be calculated here. Let's suppose it is x, right? Now I will say my answer is equals to, x is always possible, right? X is always possible. So I will say my answer equals to x currently. Now what I will do, I will say while my low is less than equals to high, is less than equals to high. What will I do then? I will say mid. The basic binary search, low plus high by 2. No problem. Now I will say if this mid value is attained. See, this question is actually very similar to allocation of books, allocation of minimum number of books. So if you have solved that question, this question is a cake for you. Allocation of minimum books, right? And this problem is similar to aggressive cows also. So if you have practiced binary search previously, this question is a cake work for you and you will be able to correct it, right? The only thing you might be stuck at is double. You want to know how to deal with double values, right? Because it is not a good condition here. I will tell you in the certain way how. I will tell you, just give me a minute. So mid equals to low plus high by 2, no problem. Now I will say that normal if check function, if mid is possible for array, and I will send my k. If this value is possible, I am saying, suppose my low is starting from 0, my high is starting from 4, my mid will be in first iteration will be 2, right? My mid will be in first iteration will be 2. Our approach says check for mid. Our approach says check for mid. If this 2 is actually attainable in the current scenario, that is 1, 5, 2. If mid is actually attainable in the current scenario, that is, if I'm able to get a maximum distance of 2 by putting station between 1 and 5, then your mid is a potential answer, right? Then your mid is a potential answer. So 2 is a potential answer here. Now what you can do is, you can see that if 2 minus 1 is also a potential answer, your approach should be to see if 2 minus 1 is also an attainable answer. So you will say if check mid ARRK, then your high changes to, let's say, mid only. You can say mid minus 1 also, let's say mid. Why mid, I will be telling in a short while, right? Otherwise, if 2 is not attainable, that means 3 is also not attainable, 4 is also not attainable, right? Okay, that means 1 is also not attainable. If you are not able to get a minimum difference of 2, that means you will not be able to get a minimum difference of 1 also. So in that case, your low will increase. So you will say low equals to mid, low equals to mid, low equals to mid. Now the question states that you have to provide a double value with a precision of 0.2. Like you will have to give me the exact value up till second decimal place, right? That is 0.00, something like that. Now this operation is somewhat not aligning with my sequence. Why? Because in the double cases, it will just reduce, and it will never be equal. It will never surpass, right? It might be possible that the values get minimal as possible, and it will take a lot of time. It will give a TLE error. So to avoid that, we will be saying high minus low is greater than some value. Let's say I always take 1e minus 9. So high minus low should be greater than this value. Up until then, please run your loop. Otherwise, don't run. Right? So I will say high minus low is greater than 1e minus 9. So until then, please run your loop. Otherwise, don't run. And that is why I use high equals to mid and low equals to mid plus 1. Low equals to mid. Instead of I didn't use minus 1 and plus 1 here. There was a reason behind it. What is the reason? So I am saying your low is here, your high is here, Your mid is here, right? Your mid is here. So if I use low equals to mid plus 1, suppose mid comes out to be 2 and I say low equals to mid plus 1, that is, you are actually giving low a distance of 1, right? You are actually giving a low distance of 1. But it might be possible that low, that the actual answer is actually between this. That is, it is somewhat mid plus, let's say, zero point 0.3. It might be a possible answer, right? So in that case, this condition will actually give you a wrong output. That is why I said low equals to mid and high equals to mid. So not to avoid these values, these certain values, right? So I hope that is fine with you, right? Now, how to see the check function? Our check function is also an important part of the question, right? Check function. So our test case was 1, 5, and we have to insert 2. We have to insert 2. So two stations, right? So what I will do is I will first keep a counter. As I said, this is actually very similar to the aggressive chaos problem. So I will actually keep an answer. Count equals to 2. That is how many stations have you inserted. Count equals to 0. How many stations have you inserted right now? Up till now, you have not inserted anything. Move from the first index. Why first index? Because you will be inserting here, right? So you just want the adjacent difference. So I will moving from I equals to 1 up till n minus 1. That is, in this case, only 5 will be my answer. My difference is array of I minus array of I minus 1. Correct? My difference is array of I minus array of I minus 1. Now, it might be possible that if my difference is actually less than equals to mid, but I want the difference to be less than equals to mid, right? So if that is the case, do nothing. Do nothing. Continue, right? To continue. Else, if that is not the case, that means I have to find the distance for 2. I want to minimize the difference to 2. So that means I have to insert stations here because the difference currently is 4. The difference currently is 4. So I will have to insert the stations here. So this is at 1 and this is at 5. 2, 3, 4, right? These are my stations and I can insert anywhere. Double values are also possible. So what I will do, how can I find that I want to get the distance of 2? So that is the case 5 minus 1 by 2, that is 4 by 2, that is 2. I will have to insert 2 stations. I will have to insert 2 stations to get the difference of 2. I did array of I minus array of I minus 1 by mid to get that, and that is simple division to get k value I wanted, right? Else I will say it is else count plus equals to difference by mid, right? Moving forward, when I will return true, if my count is actually less than equals to k, that is I only put the stations I wanted to, right? In that case, return true. Else return false. Else return false. So I hope that is clear with you, and let us try to code it down. I hope that was not a lot of hustle bustle for you, right? So let us code it down. Alright guys, so here we are in the coding section. Before starting to code, I would like to request you to please subscribe to my channel because it gives me a really lot of motivation, right? So let us start. First of all, I will get the station size. So STAS, yeah, size. This will give me the size of the array. Now what I will do, I will say my current low, that is double low, is equals to 0.0, and double high I want to find. Double high equals, let's say, equals to 0.0 currently, right? I will have to find it equals to 0.0. Now what I will do, I will say for int I going from 1, I less than n, I plus plus, high equals to, it will be high equals to maximum of high, my comma, stations of I minus stations of, that is find the maximum adjacent difference, right? Now my one potential answer is, that is I want to find an answer less than equals to high, because high is always achievable, right? It will be answer, right? Now moving forward, I will run my loop while my high minus low is greater than 1 e minus 9, right? Because that is a very small value, right? Now my double mid will be equals to high plus low divided by 2. High plus low divided by 2. And let us take a 2.0 for better precision. Double mid equals to 2.0. If check for mid, stations and k is true, in that case my answer will change to mid and my high will change to mid, right? High will change to mid because it might be possible to find an answer lower than the current answer. Now otherwise that is not the case, so low equals to mid. Moving forward, I will simply return my answer. right? So let us just define the check function now. So check function is actually returning a bool value. So bool check, taking a mid value, int mid, taking stations. So it is sta, okay, taking station. So vector int, and I'm naming it as arr for better writing, right? Int k remains same. Moving forward, what I will do is I will say int count equals to 0 currently. Now for int I equals to 1, I will go up till last element, that is n minus 1 I plus plus. What I will do, I will say my first distance is equals to array of I minus array of I minus 1, correct? Now it might be possible that distance is actually, if distance is less than equals to my mid, that is I don't want to insert any station, in that case simply continue, else count plus equals to difference by mid. This will actually add the number of stations that need to be inserted to actually minimize the difference up till mid value. Now I will just return count less than equals to k, right? So this is my whole code. Hope it will work. Let us try to compile and run it. Alright, so this is giving an error that it is not possible to put a max in the double function. So I will just say if high is less than stations I minus stations I minus 1, in that case updated. So high equals to stations I minus stations I minus 1, right? Let us try to compile and run it now. It should, as you can see, it is running fine. Let us try to submit it as well. It should work fine, I guess. It is running, and you can see 159 days streak, guys. Thank you for watching, and we'll meet tomorrow with a new question. Till then, please keep watching, stay tuned, and keep supporting. Thank you. Have a nice day.